Hey, everybody.
Hello, Professor.
How's it going?
All right, how are you?
Good, good.
So I downloaded and started up the program.
Mm-hmm.
I don't have to do anything else to it.
Nope. Yeah, so we'll be going over the whole thing today. Yeah.
Okay.
Mhm.
Hey, Professor.
Hey, what's up?
I have Ansys 2021 R1 versus R2.
Yep.
Is that a big deal?
Yeah, that's fine. I have R1 too, actually.
You do?
I can't show it here, but yeah, if you have R1, it's totally fine. It's kind of like textbooks, and so they don't change too much in between the versions. They just have to come up with an excuse to sell people a different version of it. So
Yeah.
for our purposes, you know, we're going to be sticking with I mean, we'll do some more advanced stuff later, but even that doesn't really change all that much between versions. So yeah, you should be good.
And I want to open it up so I have it ready. What do I open up? There's like 50 different things I downloaded.
Yeah. You have to open up a program called Workbench. And so if you go down, it's at the bottom. Yeah. So Workbench is the program that launches all the other ones. And so it's the starting point of yeah, it's a starting point of using Ansys.
Got it. Thank you.
Mhm.
I liked your cat, or the kitty cats.
Oh, my cat? Where?
Yeah. When you click on the start menu.
Oh, yeah, that was my, so this is the cat I had in grad school. It's not my cat now, but I can show you guys. Yeah, this was the cat I had in grad school, but my parent has it. My parents have this one now. My cat is this one. This is my current cat.
That's the one that was hungry.
Yes, yes. Yep. Yeah, actually, this is my fiance's cat. And then, you know, we moved in together, and so I also adopted this cat too. So
Is it indoor or outdoor?
she's indoor, very indoor. She would not survive outdoors at all.
Yeah, cool cat either way.
Yeah.
As
she's
most household pets, to be honest.
yeah, yeah. I mean, she's an old lady, and so it's she's 16, a little bit over 16 years old now. So yeah, she doesn't move super well, but she knows when she's hungry.
Yeah, it's kind of funny.
Yeah.
Our cat, we let her out, and then around noontime she comes in, and that's when we close up the doggy door. Because we used to have dogs, and so when we had dogs and cats, it was kind of pain in the ass trying to like keep the cats inside, but like the dogs have to go use the ocean. So we said, fuck it, just have the door open.
Nice, nice.
Yeah, I've known people. I was watching someone on Twitch the other day, and they play like a bunch of like Kaizo Mario and stuff like that.
Uh-huh.
And everybody can see like her cat's name is Pete. She's a space nerd or whatever, so it's Pete Conrad is who it's named after.
Nice.
And Pete is constantly like running around on the sofa doing what looks like inappropriate things to like a blanket. And then like 10 minutes later, Pete's like slamming doors in the kitchen looking for more food. And
Oh,
she's like,
goodness.
I just fed him. There's no reason for him to be like slamming stuff, but he knows where it is.
Uh-huh.
So he's always, yeah, it's fun.
Yeah, cats are superfood motivated. Every new person is a new opportunity to get fed too. So every new person that comes in is like,
That's exactly right. Yeah, I grew up with a cat we named Mocha because they drinking out of my dad's coffee cup, and yeah, she was a good cat.
That's sweet.
I had a one of our old dogs, Riley. When he was a pup, my dad smoked some meat and wrapped it in tinfoil, left it on the counter. Went to go answer the phone. He went up, took the meat, and ate everything, including the aluminum foil.
Oh goodness.
And
Oh
when
no.
my dad saw that, he said, "Like, I hope you shit out aluminum."
Yeah, you have to be careful. Yeah, the pets will know when there's food out there. Yeah, we always have to watch our cat too, because like if we leave any food on the kitchen table, like she will, yeah, she will get
She'll
there.
eat it.
Yeah.
Yeah.
When I was a kid, my cat thought it was fun to like jump inside the dryer while my mom was like
Oh.
loading it,
Uh-huh.
and she didn't see.
Oh no.
And so she closed the door and turned it on, and apparently when the cat tumbled enough, she knocked the door open. So luckily it stopped.
Okay.
And she fell out. But we heard, I don't know how long she was in there, but it was a decent amount of time. And we found her or whatever, and her eyes were all kind of like glazed over, and she would only walk in a circle backward for like a week or whatever. We rushed her to the vet thinking like we killed her, but yeah, no, she was fine. Just like really, really didn't like the laundry room after that.
Oh. Well, it's good. It's good she was okay. I mean, that's scary because like sometimes you don't know. Like you're just tossing a bunch of clothes in there and they sneak in, and then I think they like that too because they see a bunch of stuff flying and then it interests them, and then they kind of jump in after that. But yeah, glad she was okay.
Yeah. Our old cat Her favorite thing was, or her, not food wise, but just for some reason, it's just she loves ice cold water. Like whenever we get water, it's like, or from the fridge, it's like she's waiting for you. She's looking at you. It's like, are you going to give me some of that water? Are you going to give me some of the ice cold water?
That's funny. Some cats will even like learn how to like turn on like fridge water themselves. Like I've seen videos of like a cat like going like this and pushing it with their paw and then like just like licking the water that comes out.
Also heard is that you can get them used to water if you introduce them young using like a warm bath or
Mhm.
something like that. So they get used to water, so they won't be as scared near water.
That makes sense.
Oh, hello.
Hey, how's it
Hi.
going?
Okay, thank you. Sorry, Dr. Tran, did you receive my my email today regarding the project that I was just mentioning?
Yes, yeah. I'm a little bit behind just because like first week, you know, everyone's sending me emails
Yeah,
about stuff.
I
So,
get it.
but
Yeah, I just
I
wanted
did get it. Yeah.
yeah,
Yeah. I'll respond. Yeah, either later tonight or tomorrow. Yeah.
thank you.
Mhm.
Did I hear right, Dr. Tran? Your test came back negative.
Yes, yeah. So I was going to talk about it today. So starting next week, you know, we'll be meeting in person. But with that said, you know, some people still kind of feel a little bit uneasy coming to campus, and so I'm going to try to do kind of like a both, like to accommodate boths. But we'll see how it goes. But right now my plan is to teach in person, but also have like a webcam on there with Zoom. And so if you know if people feel like you know they don't want to come to campus, then you can at least follow along there. It's not going to be super ideal because it's you know it's going to be hard to see the entire board, but at the very least like you can hear what I'm saying. And I tend to follow my lecture notes really closely too. And so if you follow along with that and then kind of listen to what I'm saying, then hopefully that might be hopefully that might be enough. But yeah. But on the days that we're doing the Ansys activities like today, you know, I'm just gonna be working at the workstation anyway, and so it'll be, you know, I think it'll be a little bit easier to have those be remote. Okay, it's 5:30, so let's go ahead and get started today. All right, good afternoon, everyone. How's everyone doing today?
Doing all right.
Good.
Good. Yeah. So in case you just came in just now, so my COVID test did come back negative. And so I'm very glad for that. I guess I just had like a cold this week or something. So, and so next week we're gonna be going back to in-person instruction, or I guess, you know, starting it up, I guess we never, you know, we never started up. And so, you know, this will be the last day we'll be having it an arrangement like this. But with that said, you know, a few people have come to me and said that, you know, it's coming to campus is still a little bit, you know, they still feel a little bit uneasy about that. And so I'm going to try to do kind of almost like a hybrid kind of approach, although it's not really hybrid the way that they think about it. And so I'll be teaching, you know, in person in the classroom with the whiteboard and everything. But you know, for those of you who want to attend the lectures virtually, you know, I'll be bringing my laptop with the webcam, and I'll try to put it in kind of a central location in the classroom, and I'll turn Zoom on there, and so you'll be able to listen to what I'm saying, and hopefully you'll be able to see a little bit of the board, you know, from there, right? I think it should be okay, because I think with the computer lab, I think there should be a desk or a chair that I can put the laptop on. So and so, you know, we'll try it out. But you know, but so we'll go from there. But I'll send an email out that has more information about this too. But yeah, the plan for now is to next week we're going to go back in person. Okay. All right, and so for today, we're going to be doing our first Ansys activity, and so we're going to be diving right into the software. Okay, After reading your guys' emails and also just kind of knowing, just kind of after teaching this class a few times, I know a lot of people are coming into this class with a strong interest to learn how to use Ansys. So I thought, let's just get right into it. Let's jump right into the, and how to use the software. Okay. And so today we're going to do, I think, probably one of the simplest cases you can do in Ansys, which is we're going to do a simple case where we have a plate, a rectangular plate. We're going to drill a hole in the middle of it, and then we're going to be loading it with a tensile load. Okay. And so the plate is going to be fixed on the left-hand side, and then you're going to be pulling on it on the right-hand side with the pressure P. Okay. And so let me just fast forward a little bit just to kind of show you what you can expect from the results. Okay. And so from the results, you should get something that looks like this. Okay. And so what you're going to see is a basically what I call a color contour plot, where we have the your plate, and it's going to be deforming as a result of the load. Okay. And then the colors on the plot and the colors on the figure will indicate areas where the deformation is highest. Okay. And so if we have, if you can see here, the red color indicates a deformation of about, I can't remember that, 2.5752. Okay. And then the blue areas are, have no deformation. Okay. And so this is what you can generally expect from a finite element analysis. Okay. And so from finite elements, you can basically expect to see kind of a very nice picture of the of how deformation is distributed, and also you can look at stress distributions as well. Okay. All right, but we're going to go through kind of the entire process today, and so it'll be, I expect today to kind of take up the entire time, because I know for a lot of you guys, it's going to be the very first time you're opening up the software, and so we're going to go really slow. We're going to go over each point really carefully just to make sure everyone's keeping up. Okay. All right. So are there any questions I can answer before we get started for today? Okay. All right. Oh, actually, one more thing. So I know we didn't get a chance to do this last time, and so I want to give a quick tour of the course website just so you just so you know where everything is. Okay. All right. And so here is the course website. Okay. And so it's on Canvas. And so when you log on to Canvas and you go to our course, this is what you see. Okay. So here you see the name of the course, right? So Introduction to the Finite Element Method. Here's my name. Here's my email. Okay. You can click my name. And then you can look at my, Tinder profile for teaching if you really want, but it's not that important. Okay. Our class times are, Tuesdays and Thursdays from 5:30 to 6:45, but you guys know that because you guys are here. Okay. And our location starting next week is going to be CS 309, which is the special instruction room. Okay. So it's one of the computer labs in the CS building, 3rd floor. Right? Okay. So from here you can see the I've written a little brief description of the course. Here are our course level learning objectives, which we went over last time. Okay. Oh, quick question. So are we able to save our Ansys files on OneDrive? Yes, you should be able to. And actually, I think that would be kind of an ideal thing, so that when you work on stuff in the lab, you can send the files back to yourself through OneDrive. Yeah. And at the end of class today, remind me, and then I'll show you how to save the results, because it's not the most straightforward thing compared to other softwares. Okay. All right, question, is it okay if we still don't have the software today? Yeah, it's fine. And so today's lecture is being recorded, and so you can go back and watch the lecture later and then use that to walk you through the software. Yeah. And actually the PDF that I've uploaded for today's activity, it goes through every step, kind of step by step too. And so if you want to, you can just follow the PDF as well, and then that will tell you exactly what to do. And so actually, even if you have the software, if you just want to sit and just watch and listen today, I think that's fine too. Because I think for a lot of people it's kind of hard to switch between Zoom and Ansys at the same time. And so if you want to just spend today just kind of watching how I do things and then apply it later, I think that's a perfectly valid way of going about it. Yeah. Okay. All right. And so here's the syllabus. And so if you want to download the syllabus, you can just click this link. Okay. Oh, question. So where can we download the Ansys software, and is it possible to install on multiple computers? Yeah. So they offer kind of a completely free student license, and so there's no limitations on how many computers you can download it on, right? I don't think you don't even have to make an account on the website. And so if you look at the announcement that I sent yesterday, and so on the announcement that I sent yesterday, there's instructions here on how you can download it. And so you just have to go to this link, and then you just download the software from there. Yeah. Mm-hmm. Okay. All right, question. So what are the differences between the student versions available on the website? Yeah, it's a good question. So let's go to the website now, and just so we can kind of talk about that briefly. All right, and so if you go to the link that I provided, then here is the here's the website. Okay. Yeah, so we'll go over that in a bit. See, Ansys actually installs quite a few programs, but the one you want to open is called Workbench. Yeah. And so the one that you want to download is just Ansys Student, which is this one right here, right? And so these ones are a little bit more specialized. Let's see. I think LS Dyna is something that's a little bit more specialized for automotive and aerospace. And so actually I don't have any experience with LS Dyna, even though I know it's used quite a lot. But the one that we're going to be using in this class is Ansys Student. And this is the one that's kind of best for structural simulations, which is going to be the focus for this class. Yeah. And then obviously this one is for electronics, which I've personally never touched before. And so you want to download just Ansys Student right here. And so all I have to do is just click download now. And then it'll take you to a page. I think people were saying that the R2 version is out. Yeah. And so you'll be downloading Ansys Student 2021 R2. And that's totally fine. Okay. Okay. Right. Okay. And so here's all the Zoom links for my office hours. And so remember, if you want to join office hours virtually, you can do that from these links. Okay. And then there's also the link here for the Discord server. Okay. And so the Discord server is really important, especially for days like today, because typically, for these Ansys days, and when we're doing this in person, usually it's really easy for me to kind of go around to different desks and help people out when they're having issues. But with the Zoom, and especially, for people who are going to be joining this virtually, it's a lot harder for me to go around and help people out with their Ansys troubles, just because of the limitations of this medium. So usually what tends to happen when we have class in person is that, if one person is having issues with their Ansys or they're not sure what to do, you just kind of turn to the person next to you and say, hey, I'm having some issues with this. Can you help me out with that? And so that's a lot harder to do with Zoom. But that's where the Discord server comes into play. Okay. And so if you go to our Discord server, and actually let me add these people that just joined just now. Okay. And so if you go to our Discord server, you'll see that there is a channel for questions. Okay. And so throughout today's lecture and beyond too, if you're running into an error on Ansys or you're not sure how to do something, try this one first, especially during the lecture, because it's a little bit hard for me to kind of stop what I'm doing to kind of help an individual people over Zoom. Whereas, it's a lot easier in person. And so, if you're having issues today, definitely get on the Discord and ask some questions there. And see if you guys can help each other out, because I think that'll help the lecture go a little bit more smoothly. Because otherwise, I'll be stopping and trying to help people, and it's a little bit disorienting. And so, try this first, and then if multiple people are having issues, then you can bring that to my attention, and then I'll help everyone out with that. Okay. All right, one new person just joined. Okay. All right. And so that's the Discord server. Okay. But probably where you're going to spend most of your time in the on the course website is on this weekly viewer. Okay. And so you can see here at the bottom, I've broken down the semester into each of the 16 weeks. Okay. And then as we get further and further in the semester, these links will become clickable. Okay. So let me go ahead and click week 1 just so that you can see. Okay. And when you click on this, it'll take you to a new page. And then on this page, you'll see, everything that you need for the week, right? And so you'll see here that I've written kind of a short blurb for the week, right? I've listed out all of the learning objectives. And I've also listed out the assignments, okay? And so you can see here that your introduction assignment is here. And also the Ansys activity assignment, which is due next Friday, is here as well, okay? So you can click these and you can get more information on these, okay? Right, and so you can see here that you can download the document here. Okay. and also all the files here. Okay, and so basically any activity file or any lecture notes that I create will be posted here on the week. Okay, and so I organize it per week because it's I think it's just a natural chronological ordering. And so if you're wondering what materials you need for the week or what notes that I'm going to go over, check the weekly page for this one, and then you'll be able to see. Okay. All right. One more person. All right, and so that's the home page, and that's the weekly viewer. Okay, so definitely check these out. And so I update these pages, the week before. Okay, and so by tomorrow, this week 2 will be clickable, and you'll be able to download like all the lecture notes and see the learning objectives for that upcoming week. Okay. All right, and so besides the home page, there's also other tabs here. So we can go to the announcements page, and so the announcements page, you can see all the previous announcements. Okay. Then you can click on assignments, and so assignments will show you, what assignments I have that are out there and when they're due. Okay, be careful reading this because people have made this mistake in the past, and so I have 2 dates here. Okay, and so there's the available until date, and then there's the due date. Okay, and so I set the available date a week after the due date just in case people want to turn in late, but it's actually due on this date right here, which says due. Okay, and so don't turn it in on the 10th and expect that to be on time. Okay. All right, question. So if you're still on the wait list, can you still do the introduction so we don't miss out on points? Yes, you can. Yeah, so if you're still on the wait list, definitely still send me an email to introduce yourself, and then I'll give you credit for that once you're added into the class. Yeah. All right, and so here we have a tab for the grades, and so you can see, how many points you got on each assignment, and then it'll have a calculation for your total grade. Here is here's the breakdown for how the grades are. Okay. There is the people tab, and so you can see, the names of all your classmates here. Okay. And then here is the files tab. Okay. And so, you can access all the files from the weekly viewer that I showed you before. But if you're looking for a specific file, then I think this is probably a better place to look for it. Okay. And so this is kind of like the raw kind of Dropbox folder for our class. Okay. All right. Any questions on the course website? Okay. All right, and so that's the course website, and so I'll be using that a lot this semester. So definitely get used to it. Okay? And so now we're going to start our activity. Okay, and so in this activity we're going to be doing a simulation on a plate with the hole. All right, and so here's the physical situation. So we have a 2D plate. Okay, the plate is going to be fixed on the left-hand side, right? And so this is where it's going to be attached to a wall, and then on the right-hand side we're going to be pulling it with a pressure P. Okay. And the dimensions of the plate are its length and its width, and our hole has a diameter. And then here is all these all the parameters. Okay. Okay. And so we want to simulate this guy in Ansys. And so our first task is going to be to open up Ansys. Okay. And so if you're in the computer lab right now, or if you're working at home, you want to open up Ansys. So open up your start menu, and then go to Ansys 2021 R1, okay, or R2 if you downloaded that one. And then you want to open up the program called Workbench 2021 R1, okay. And so as someone noted earlier that, Ansys downloads, honestly a shit ton of programs here, right? But the only one that you need to open manually is Workbench, okay. And so what Workbench is it's kind of like the hub where all the other programs launch from. Okay, and this is where you save your projects to. Okay? And so it takes a couple minutes to start up Workbench, especially if it's the first time. And so I'll pause here a little bit. But once you have Workbench open, you should be greeted with this screen right here. Okay. All right. So was everyone for everyone who's following along, are you able to open up Workbench?
Good.
Yep.
All right, cool. Okay. All right. And so, Workbench, there's kind of a lot going on here. And so let me kind of show you kind of what to see. Do we need the properties on the right? No, you don't. So actually, let me close this. And then there's a way to reopen it on the right. And I'll show you in a bit. Yeah. But the only thing you should have is kind of a big blank project schematic here. And then all of these analysis systems on the left. Yeah. Okay, and so first thing I want to draw your attention to, this analysis systems on the left-hand side. Okay. Okay, and so what this section shows you is these are all the different types of simulations you can run in Ansys. Okay, and so you can see there's a lot. Okay, and so Ansys is a big program with a lot of different capabilities. Okay, and so we'll be going over quite a few of these in this class, but we're not going to be able to go over everyone. And in fact, if I can be honest, I haven't even used, probably 70% of these myself. I've only used kind of the main ones. Okay. And so one thing that I will say is that, from this view, it's kind of hard to see which ones are, which ones are actually useful and which ones do you need. And so that part I don't like. And so, in order to actually start using this, I think there's a huge barrier of entry here in terms of like, what you can actually click and what's actually useful. Okay. But for most of this class, we're going to be doing a structural simulation. And in fact, we're going to be doing one that's static. Okay. And so our simulations are not going to change with time. They're going to represent just, static equilibrium situations. And so the type of analysis that does that is called static structural. Okay. And so that's given by this analysis system here. Okay. And so what you want to do is you want to click on static structural and drag it. And then you want to drag it into your project schematic here. Okay. And so once again, you're going to click static structural and then drag it over here. Okay. And then once you do that, you'll create a static structural analysis here on your project schematic. Okay. Okay. So is everyone able to do that?
Yep, no problem.
Good, good. Okay. All right. And so our first step in doing any kind of finite element analysis is to define the geometry, right? So if you recall from our lecture on Tuesday, the first step is to kind of, tell Ansys what the heck you want to do a finite element simulation on. Okay. And so for our case right here, our geometry is denoted by our plate here, right? And so we have a rectangular plate with a hole. Okay. And so the first thing we need to do is we need to define that geometry for Ansys. Okay. And so hopefully you remember some stuff from CAD, because we're essentially going to be doing a CAD drawing here. Okay. And we're going to be doing this within Ansys, right? And so Ansys itself comes with a couple CAD programs. And so one of the CAD programs is called SpaceClaim, and the other program is called Design Modeler. Okay. And so I'll say that, both of these they're passable, they're sufficient. But if you want to do a serious CAD model, you're probably better off using something you're more familiar with, like SolidWorks or CATIA, right? But for this case, since it's a very simple geometry, we're going to draw this from scratch within Ansys. Okay. And so I want you guys to right click on geometry here. Okay. And then after right clicking on geometry, you're going to click on the second option for new design modeler geometry. Okay. And then what that's going to do is going to open up a new program called Design Modeler, where we'll be able to draw our rectangle geometry. Okay. And it's going to take a little bit of time, and it might seem like the program's doing nothing, but if you look in the bottom left of the screen right here, right? And so you can see that Ansys is saying it's starting Design Modeler. It's just being slow because it's it's a whole nother program. Okay. And so after Design Modeler loads, it should open up a new window, which is should look like this. And so it's going to be another empty window. Okay. Sure. Yeah. And so what you want to do is you want to right click on geometry, and then you're going to click on edit geometry in Design Modeler. Yeah. Okay. All right, so is everyone able to open up Design Modeler and to get this screen right here?
I got a different screen by double clicking it. I'm guessing that's not the right way.
Yeah, so if you double click it, then you're going to open up the other CAD program, which is called SpaceClaim. And so SpaceClaim is their newer one, which they're trying to which are trying to market more. But for really simple cases, I find that design modeler is a little bit easier. Yeah, new design modeler is fine. Yeah, if it says new design model or edit geometry and design modeler, you know, both of them are okay. Yeah. Okay. And so now that we're inside design modeler, we're going to start, you know, drawing up the geometry. Okay. Okay. So first thing we want to do is we want to center our view. Okay. And so you can see right now we're kind of, you know, at an oblique view right here. Okay. And so we want to draw this sketch in the XY plane because that's going to be the easiest thing for us to do. Okay. And so to do that, I think the easiest way is to look in the bottom right of your screen. Okay. And so in the bottom right of your screen, you can see here that we have the X, Y, and Z axes. Okay. And then you're going to click on the Z axis. Okay. And then what that's going to do is it's going to center the view on the Z axis here. Okay. Okay. And so from here, we're going to need to start drawing our rectangle. But first, we need to change the unit system. Okay. And so if we look back at our PDF, you can see here that our units are all in millimeters. Okay. And so it'll be really useful if the units within design modeler were also in millimeters. Okay. And so to change the unit system, you can go up to the top of the screen. Okay. And so the top of the screen, you want to click on this button right here called units. Okay. Okay. And then under units, you're going to select the option for millimeter. Okay. And so the default here is meters, but you know, for our case, we want to switch to millimeters just so it'll be more convenient for us to draw the geometry and dimension it. Okay. Okay. All right. And so that's you know, now that we've changed the units, we're ready to start drawing. Okay. And so to start drawing, we can go to this sketching button right here. Okay. And so on the middle left of the screen, you know, you should see a button called sketching. And so I'm going to click that button. Okay. And then next we're gonna create a rectangle, right? Because our geometry is essentially a rectangle. And so you're going to click on this button right here for rectangle. All right. And so let me go click rectangle. Okay. And then from here, you can just draw the rectangle as if it was like MS Paint or SolidWorks, okay? And so it doesn't really matter how big you draw it because we're going to dimension it soon anyway. And so just go ahead and draw a rectangle in the space, just like that, okay? All right, was everyone able to draw the rectangle?
Yeah.
Okay, good. All right, and so the next step that we're going to do is we're going to dimension this rectangle to make sure it has the appropriate dimensions, okay? And so the dimensions tab is right here. Ooh, that's not what I wanted. Okay, let me go back to the other one. Okay. So the dimensions button is right here, okay? And so we're going to click on dimensions, okay? Let me clear some of the screen. So let me go ahead and highlight dimensioning again, or I guess it's gone, right? And the first thing we're going to do is we're going to do a general dimension, okay? And so what this will do is it'll allow us to set the length of this side and the length of this side, okay? Because we want to set these to match up with our drawing, okay? And so from our drawing, we can see that, you know, the length of the plate is 300 millimeters. And the width is 200 millimeters. Okay, so let's go ahead and set that in our program here. Go ahead and clear these. Okay. All right, so with the general dimensioning tool highlighted, go ahead and click on this edge. Okay. And so that'll create a new dimension, which we'll call it H1. Okay. And then we're going to click on this vertical edge right here and bring it out. And that'll create a vertical dimension V2. Okay. All right, and so to set these dimensions, what we need to do is we need to go to the bottom left of the screen, and we're going to set these dimensions here. Okay. All right, and so let's set H1 first. And so H1 is the length of the plate. And so we're going to set this to be 300, just like in the specs. Okay. And then next is going to be V2, which is the height of the plate. And we want to set this to be 200 millimeters according to the problem specs. Okay. All right.
Professor?
Yeah.
Mine is not, it's not changing. Like it's like right now it's at 33.5 meters and I'm trying to change it to 300 millimeters and it's not changing. It's just going back to the original value.
Did you make your units into millimeters up here?
Oh, sorry.
Yeah. Try that. It might be some really big value. And so when you change it to 300 millimeters, you might have to zoom in quite a bit. So kind of use your mouse wheel to zoom in a lot. Or you can just kind of starting over might be a kind of an easier thing too. Yeah. Okay, so was everyone able to dimension the rectangle 300 by 200?
Yeah.
Great. Okay. And so the next thing we need to do is we like to center this rectangle on the origin, because right now it's we have our right dimensions, but it's not centered, and so it looks a little bit weird. All right, question. So is there a way to display the dimension on the sketch? Yeah. So I think that's typically how it's done in SolidWorks, but I think the standard in Ansys, I think, is to not display it, and so it might be somewhere here on the display, but I've honestly never tried. But I think it's I feel like there should be one. It's probably somewhere here on the view options. But usually I just look at the dimensions down here. Yeah, there's kind of a reason why they have it down here, and we'll get into this later in the semester when we get into optimization. But this kind of allows you to kind of optimize some aspects of the geometry. Yeah. Okay, and so now what we want to do is we want to center this rectangle on the origin. Okay, all right. And so in order to do that, we need to set the distance in between these two these two edges right here. Okay. And then we need to set the distance vertically between the x-axis and the horizontal part. Okay, so let's do the horizontal dimension. Okay, and so we want to set the horizontal distance between this edge and then also the y-axis here. Okay, and so when you click both, it's going to create a new dimension called H3. Okay, and so actually, I did that a little bit fast. Let me kind of highlight that again. Okay. And so in order to set the horizontal distance, you're going to switch the dimensioning tool from general to horizontal. Okay. And then after you do that, you're going to click on the left edge of the rectangle and then the y-axis right here. Okay. And then what you're setting here is the horizontal distance in between those two vertical lines. Okay. And you can see here that the horizontal distance right now is 41.775 millimeters. Okay. But in order for this to be centered on the origin, we want to set this to be 150 millimeters. Okay. Right. And then we're going to do the same thing, but with the vertical dimensioning tool. Okay. And so we're going to switch now to vertical here. Okay. And then we're going to click on those two edges. You can see we've created a new dimension V4. Okay. And then we're going to change this length here to 100 millimeters. Okay. Right. And so now we have our rectangle that has all of its lengths constrained, and also its position in space is also constrained. And so you can see here that the colors of all of these lines here are turned, a solid blue. And so that tells us that this rectangle here is fully constrained. Okay. Yeah, so there's a question, is there a way to remove a constraint? Yes, and so if you want to remove a constraint, you'd have to do it here on the bottom left. And so if you right click one of the constraints, you can click delete. And then that's going to delete one of the dimensions, or it should. Yeah, and so if you right click one of the dimensions here at the bottom, it should delete it. Yeah.
Hey, Professor, how would you constrain the left bottom dot to the origin?
The left bottom dot to the origin. I think probably the easiest way to do that is to when you're drawing your rectangle is to start it from from here, and then it would automatically snap to the origin and then go like that. Probably another way is you can probably set these to 0. Oh. Yeah, but I think probably the easiest way would be just to kind of draw the rectangle and snap it to the origin when you're first drawing it.
Okay, thanks.
Okay, and so that's the so that's how we dimension this this guy. Okay, so now our rectangle is good, but we're not done yet, and so we need to draw our hole that's in the middle of the rectangle. Okay. Okay. Oh, did I cut off for a little bit? I saw that this said connecting for a second.
Yeah, for a second.
Okay.
I'm still having a bit of an issue because just like the other person, I drew my rectangle on the bottom left corner precisely on the point of origin, and I'm trying to shift that. I'm still having issues trying to break that apart so that I can center it properly.
I see. I see. Probably it might be probably easier just to just delete the rectangle, and so just kind of just right click delete. And so if you want to do it from here, I think probably what you're doing right now is there's a sketch right here. And so if you go back to modeling tab here on the design modeler, and then you go to XY plane. And so if you right click on this sketch and just click delete, then you can just start the rectangle over here. Okay, and so yeah, that's a rectangle. And so now we need to draw our hole. And so to draw our hole, we're going to use the circle tool. Okay. All right, question. So are there any relations in Ansys where we can center the rectangle without dimensioning? Yeah, I think there probably is. I think if you draw the rectangle, let's see. That wasn't it. I think there's probably a way that you can draw the rectangle here where you start from the center and then you kind of go outwards from that. Yeah, I'm not completely sure because I haven't tried it, but I think a lot of the kind of the standard CAD stuff that you probably see in SolidWorks, I think Ansys probably has it too. It's just I'm not I'm not super familiar with exactly where those buttons are. But usually I do things with dimensioning because it's a little bit more manual for me, and it's I can kind of set everything like that. Yeah. 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 Yeah, so Isaac has a good suggestion there too. So I think that should work. Oh, I deleted one of my dimensions. Okay, and so let's go ahead and draw our hole in the middle. And so we're going to use our circle tool here. Okay, and so let's go ahead and click circle. Click on the origin, right? And so when you click on the origin, that place is where the center of the circle is going to be. And then you can drag your mouse out and to define how big the circle is. Okay, it doesn't really matter how big you make the circle right now because we're going to dimension it anyway, and so just kind of draw it out to be some certain size like that. Okay. All right, and so after you draw the circle, we can dimension it. And so let's go back to the dimensioning tool. Make sure we have general dimensioning selected. Okay, then we're going to click on the circle. And you can see here we've created a new dimension called D7. Okay, and then now we can set the dimensions of the hole, and we can go back to the problem specs. We can see that our hole should have a diameter of 50 millimeters. Okay, so let's go ahead and set this to 50. Okay, and then that sets our hole. Okay, so was everyone able to draw the rectangle with the hole just like this? Okay. Okay, great. All right.
Yeah.
Oh, was there a question?
I'm still a little behind. I'm sorry.
Oh, no problem. Yeah, use the Discord channel. I think I think try to use that and then see if somebody can help you out with that. Yeah. Okay. And so now that we have our sketch right here, now we need to actually turn it into a surface. Okay. And so to do that, we're going to use a feature within Ansys called Surface from Sketches. Okay. And so we're going to go up to this, this button up here called Concept. Okay. right, so we're going to click on concept, and then we're going to click on this button here called surface from sketches. Okay. And so what this is going to do is it's going to take our surface, which we're going to take our sketch here that we've drawn, and then it's going to turn it into a surface body from which we can, run a finite element simulation on. Okay. All right. And so after clicking concepts, let's go ahead and click on surface from sketches. Okay. And then what it's going to do is going to create it's going to change the view here in the bottom left. Okay. Okay. And so this is where we're going to set our settings for the concept from the sketches, right? And so the thing that we need to do is we need to select the sketch that we just made. Okay. And so if you're inside the modeling tab right here, you can click on this plus arrow for the XY plane. Go ahead and click on this sketch, and you should only have one because we've just done a single sketch. Okay. And then in the bottom left of the screen, you're going to click on this button called apply. Okay. And then once you hit apply, you should be able to see this setting right here called base objects, and it should say one sketch, right? And so that basically sets our sketch object here for our, for generating our surface. Okay. Okay. Next thing we need to do is we need to set the thickness of our surface. Okay. And you can see here that our thickness right now is 0 millimeters. Okay. And so we want to change this into 5 because that's what the thickness of our plate is. Okay. Okay. And so let's go ahead and set this to 5 millimeters. Okay. And then now we're ready to generate. And so now that we've set the our sketch as our base object and we've set the thickness to 5 millimeters, now we're ready to generate. So let's go ahead and click generate up here. Okay. And then once you're done with that, you should be able to have your plate with a hole, and it should be, all the areas where there's a solid surface is going to be filled in with gray. Okay. All right. So is everyone able to generate generate the plate geometry just like this?
No.
Right. So where you guys had stuck?
Clicking generate and nothing happens.
You click generate, nothing happens. Do you have this surface sketch 1 right here?
Yeah. Oh, there it goes.
Yeah.
Oh no, yeah, I clicked on it.
Uh-huh. Oh, does it work now?
No, like it highlights green like yours, but then when I click away from it, it's just a sketch again.
Oh. And so when you click this, it becomes green.
Yeah.
And then when you click away, it's just the sketch.
Yeah, correct.
Okay. But the green thing looks like this, right? Like it has a hole in the middle of it. And then
yeah.
Okay. I think should be okay. I mean, ideally it should be gray. Like when you click on kind of anywhere else here, it should turn into a gray surface. Yeah, the fact that it's a sketch is a little bit it's a little bit weird. But yesterday I ran this activity yesterday with my graduate class, and there were some technical glitches too. Yeah.
Okay.
Is there a feature similar to SolidWorks where it can give you a specific view like Control 7? Yeah, it might be in this view window here, but usually I like to click on click on the axes here. Yeah. Yes, and in the chat, yeah. So another question is how can we pan the view? And then the way I usually do it is Control and middle mouse. Yeah.
Are we supposed to click the generate button after we select it?
Yes, and so after you set the surface sketch and you select this this one sketch here, and you click generate, and then it should create this gray surface. So yeah, you want to click on this generate button right here. All right, question. So there's also an extrude command, and so the question is if it's going to produce the same results. And so for this example, actually no. And so when you extrude, you're actually creating kind of a 3-dimensional object, and so you're actually explicitly extruding it. But for this case, we're keeping it as a strictly 2D object. And so actually, like if you rotate this around, you can see that even though we've assigned it a thickness of 5, it's actually still like a 2D object. So it's actually still kind of like a piece of paper. And so this thickness right here is actually more like a numerical parameter more than it actually is adding physical thickness to this guy. And so you would use an extrude command when you want to do a 3D analysis. But for this case, we just want to do 2D. And so that's why we did the surface from sketches option. Yeah. Mhm. All right. Any other questions on our geometry here before we close this up?
I know somebody had asked earlier about the Control 7, the ISO view of stuff or whatever. If you click the little blue dot, the little blue ball in the bottom right there, it automatically snaps it to ISO view.
Oh, nice, nice. Nice. Oh, I didn't even know that. It was that blue ball was there the whole time, and I never clicked it.
I just happened to click on it by accident, and it threw me into ISO. So
nice, nice, great. Yeah. So that's something new I learned about Ansys today too. Okay. And so now that we're done with the geometry, we're going to go ahead and close Design Modeler. Okay. And so remember, Ansys is a collection of a lot of different programs, and so if you close one program, it's actually still okay, all right? And so we're going to close Design Modeler, but we're going to keep Workbench open, okay? All right, and so now that we've closed Design Modeler, you can see here that our geometry here now has a check mark next to it, okay? So that tells us that our geometry has been successfully set, okay? All right.
How'd you close it?
I just clicked the X in the corner. Yeah, so just like you would normally close the program. Mm-hmm. Okay, and actually, one thing we need to do before we move on is we need to make sure that we specify that it's a 2D simulation. Our question. So the concept we use automatically exclude the whole. Yes, yeah. So I think what it does is that whenever you create a concept, it looks for any kind of closed curves on the inside of your geometry. And so since our hole there was like a closed circle, then it kind of knows to automatically exclude that from the surface. Yeah. Mm-hmm. Yep. Okay. And so we want to make sure that we are actually doing a 2D simulation here. Okay. And so I'm going to ask you guys again to right click on geometry here. Okay. And then after right clicking on geometry, you're going to click on this button here called properties. Okay. And then after you right click on properties or click on properties, then you should see the properties window show up here on the right. Right. So I think earlier someone was asking about the properties tab right here. This is how you get it to appear. And so you right click on geometry, you click on properties. Okay. Okay. And so from this properties menu, what I want you to do is I want you to look at this line right here. Okay. And so mine is line 10 because I'm running 2021 R1, but yours might be on a different line. But I want you guys to look at the setting for analysis type. Okay. And then what I want you guys to do is I want you guys to change this from 3D to 2D. Okay. This is really important because later on when we apply the boundary conditions, we need to make sure that we can apply them on a 2D geometry here. Okay. And so make sure that you're doing this before we move on. Okay, and so the next step here is we're going to start to mesh and we're going to apply the boundary conditions. Okay, and so to do that, we're going to double click on model right here. Okay, as you can see here, if you look kind of at our static structural tree, it's kind of progressing down. And so the next step here is on model. Okay, and so you can double click this model one, or you can right click and click edit. That works too. Okay. And then after doing that, it's going to open up a new program called Ansys Mechanical. Okay. And so if you look at the bottom left of the screen, you can see here that the Ansys is trying to start up a program called Mechanical. Right? And so it says it's starting Mechanical. And so this might take a minute or two. And so don't shut down your computer or anything like that, or think that it's frozen. It's working. It just takes a little bit of time because it's kind of a heavy program. Especially if you're working at home on your personal computers, and so it might be a little bit heavy. So for my laptop, I know it takes a little bit of time because my laptop wasn't really built for this, but if you're working in the lab, this is usually a lot faster because it's those computers are pretty powerful. And so you'll have a new window open up like this, but it might take a little bit of time for it to fully load. Okay. And so eventually what you'll get is you'll be able to see your you'll be able to see your geometry here. Okay. And so give it some time. And so, for you guys, since it's probably if it's the very first time you're opening up mechanical on your computer, it might take some time. So, just give it a minute or two before it can go. Okay. Okay. So was everyone able to open up mechanical, and do you guys see your plate with the hole here inside Ansys mechanical?
Yeah, I got it.
Okay, good. Oh, one thing. So if you're opening up mechanical for the first time, they might give you like an ad or something like that, like some kind of download Ansys or whatever. And so if you get that screen but you don't see your geometry here, there should be like an X like around this region of the screen. And so you just close that advertisement, and then you should be able to see your geometry from there. All right, question. So I don't seem to see mine. Should we find it in the geometry tab, in the geometry tab? Yeah. So you have to click on model. Yeah. So you have to double click on model up here. It might still be starting up because it is kind of a heavy program. And so if you look back on Ansys Workbench, and then the bottom left of the screen right here, if it still says starting mechanical, then it's still trying to load. Yeah. So so I think the first time when you start up Ansys mechanical, you come to some start page, like it has an ad or something like that. So it's like, hey, see what's new. And so if you see that, you can just close that ad. And so I think there's either a close button here, kind of at the top left of the screen, or there's some close button down here. Or another way that you can do it is you can just click on geometry here on the left-hand side. Okay, and then that should close the advertisement too.
Was the previous one supposed to save?
Yeah, it's saved automatically, and so you don't have to save anything on Design Modeler. So it'll save, and then it'll automatically load it in here. Yeah. So actually, all the saving you're going to do is going to be from Workbench, and so you don't have to save anything from mechanical or Design Modeler. Yeah. All right, question.
Okay.
So it loaded without the model. So I think so. The first time when you open it, it'll it might not show the model, but it's probably still loading. And so if you look back on Workbench right here, and so if it does it say in the bottom of Workbench, does it still say starting mechanical down here? Yeah. So that's another thing you can try too. Yeah. And so if you click on geometry on the left-hand side, it should bring up your model.
I can't
Great.
seem to get mine to launch for some reason.
Is it still thinking?
No, the mechanical, the window it popped up. I don't see the model.
Okay, it
And,
might still be loading because usually when you first open up mechanical, like the window will pop up and nothing will show up, but it's still actually loading. So maybe like give it a minute or two. But if it's still like that, then let me know.
Yeah. The thing is, I'm not sure it's because I was supposed to have. I don't have that side panel on the right side on my Workbench window, and I remember you doing that. Yeah, that properties schematics. Is that something that I should have?
It's not required for mechanical, but there is something that you have to set in here beforehand. And so in order to get this right-hand window, you can right-click on geometry here and click on properties. And then after you click on properties, then the right side will show up here. Yeah. Unfortunately, so we haven't saved anything yet, and so if your program crashes, unfortunately, you have to start over. Yeah. Okay. All All right, so I'm going to move on just for the sake of time, but then you know, I'll come back to everyone after this. So I'll be staying after class today to kind of help people out, to help catch people up too. I know it's the first day and it's the first time we're using Ansys, and so it's a little bit disorienting for everyone. But I do want to make sure that I kind of finish the activity, you know, before 6:45, which is, you know, when the class ends. Okay, and so the next step that we have to do is we have to mesh our geometry. Okay, and so if you recall from Tuesday, you know, what meshing means is that it's going to take our geometry here and then break it up into a lot of simple shapes, you know, in order to run the simulation. Okay, all right, and so to do that, we're going to right click on this mesh over here. Okay. Right, and so when you right click on mesh, okay, when you right click on mesh, you should see a button here for generate mesh. Okay, and so let's just go ahead and mesh with the default properties, just so that you can see, you know, see what's going on. Okay. And so with the default mesh, you should get a mesh that looks something like this. You know, yours might not look exactly like this because there's a little bit of randomness when it comes to meshing, but you know, it should have the same kind of general pattern. And so it kind of almost looks like a spider's web, you know, on top of this, on top of our geometry here. Right? So is everyone able to get a mesh that kind of looks like this?
Yeah.
Yeah.
Okay, great. Okay, and so this mesh actually, you know, for this kind of simple problem, this should actually work fine. But you know, we can improve this mesh a little bit, right? Because right now this mesh is fairly coarse, and so you know, these elements here are pretty big. And so usually when you have elements that are pretty large like this, you know, you can kind of expect the results are going to be a little bit inaccurate. And so we want to make these elements actually a lot smaller than they are. Okay. And so one way that we can do that is we can, you know, adjust the size of the elements. Okay. All right. So there's a few different ways that you can adjust the size. And so if you read the PDF, there's yeah, I kind of show you kind of a little bit of a long way to do it. But that way is actually kind of, I like that way a lot better because it's kind of, you know, better for more complex situations. But just in the interest of time right now, I'll kind of show you kind of the quick and easy way to set the size for this. And so what I want you guys to do is I want you guys to left click mesh. And so make sure that mesh is left clicked here. Okay. And then on the bottom left of the screen, I want you to look at this setting right here, okay, for element size. And so you can see right now the default element size is 30 millimeters, right? Which means that each side length of the element, so like this length right here, that is about 30 millimeters. Okay, so it's fairly large, and so it's you know, not the smallest element. Okay, and so what we want to do is we want to make these smaller. And so let's go ahead and click on this box right here, and instead of 30 millimeters, let's make it something smaller, like 7. Okay. So I'm going to use 7, but you can use anything between 5 and 10. I think will work fine. Okay.
Professor, my mesh is showing, or the element size is showing it's in meters.
Same here.
Yeah. So we have to change the units for that, and so I always forget this. I think mine's by millimeters by default, but in order to change the units, you want to go to home up in the top left of the screen. And then you want to go to units right here. And if you click on units, then you can change it to metric millimeter right here. Yeah.
Gotcha.
Cool. All right. And so now that we've changed the element size to 7 millimeters, let's go ahead and regenerate our mesh. And so same thing we did before, we're going to right click mesh, and then we're going to click generate mesh. Okay. And so what that's going to do is that it's going to create a new mesh for you. Okay. And you can see here that this is a much better mesh. Okay. So all the elements are much smaller than they were before. And this is going to lead to a much higher quality solution because these elements are much smaller. Okay. And so remember what I told you before. So think of the mesh as something like a like a picture, like the resolution of a digital image. Okay. And so the smaller your pixels are, the higher quality your image is going to be. And so the same thing for finite elements. And so the smaller your elements are, the higher quality your simulation results are going to be. Okay, so was everyone able to get a mesh that kind of looks like this? Great question. So a question in the chat is there a reason not to go with the smallest element size possible every time? Yeah, that is a great question. I think a question that I think everyone should ask themselves when doing finite elements. And so the limiting factor that you have here is memory. Okay, and so if you think of a digital image, right? And so if you have a much higher resolution image with really small pixels, you can do that, but the more pixels that you stuff into it, the more memory it's going to take up on your machine, right? And so like a really high quality image is going to take up much more space than the crap JPEG that you downloaded from Reddit, right? And so same thing with finite elements. And so the smaller elements that you have, the more computational cost it's going to be, right? And so it's going to take up a lot more memory, but most importantly, it's going to take up more time as well, right? And so when you go to actually solve the simulation, if you have too many elements in your mesh, then it's going to take a really long time for it to solve. Okay. For this class, we're not going to run into too many issues like that because the problems we're looking at are fairly small. And also everyone's working with the student version of Ansys, and so they actually put a hard cap on how many elements that you can actually have. And so I think for the student version, it's 32,000 elements, and that's the max. And so once you go over that, then they tell you, you have to buy the premium version in order to continue. But realistically, for practical cases, you often want to limit the amount of elements, to make sure that the cost doesn't explode. Yeah. Mm-hmm. Yeah, and if you're interested in seeing how many elements that you have, you can left click mesh, and then you can go to the bottom left of your screen and you can click on statistics here. Okay. And if you click on statistics, you can see that we have 1,234 elements. Oh wow, 1, 2, 3, 4 elements. And so this mesh is still fairly cheap. But once you start getting into 3D analysis, that number of elements can blow up quite a bit. Yeah. Yeah. Yeah, and so oftentimes what can happen is that you can crash the program too if you use a mesh that's too small. Yeah, or mesh size that's too small. Okay, and so I'm gonna cut this off here a little bit, but there is a lot more that I say about meshing in the PDF, and so make sure you guys check that out when you're doing this assignment. Okay, but just for the sake of time, I want to make sure we get to the simulation results. Okay. All right, and so the next thing that we need to do is we need to add our boundary conditions, okay? And so this is going to be our loads and supports, okay? And you can see from the project document here that we have two boundary conditions here. Okay? We have a fixed support here, okay? Okay, and so our plate is going to be attached to the wall on the left-hand side. And then we also have a pressure boundary condition here, which is basically pulling on the plate from the right. Okay. All right. So we need to translate both of these boundary conditions into our Ansys simulation. Okay. All right. And so the way that we do this is we want to go from this setting right here. Okay. And so from static structural A5, you're going to right click it. Okay, and you're going to go to insert. Okay, and the first thing I want to do here is I want to create a fixed support. Okay, and so fixed support is basically going to make sure that whatever region that we select with our fixed support, that region is not going to move. Okay, and actually you can read the description for the fixed support here, right? And so you can say insert a fixed support boundary condition to prevent a selected geometry or mesh entity from moving or deforming. Okay. And that's exactly what we want to do, is we want to prevent the left side of our plate from deforming. Okay? And so let's go ahead and click fix support. And so that's going to create a new object right here. Okay. Right. And then we want to select just the left edge of this plate. Okay. All right. And so in order to select the left edge, we need to make sure that we're on edge selecting mode. Okay. Right now we're in this mode right here, which is kind of like smart select. And so if we try to select something with this, we end up selecting the entire plate, which is not what we want, right? All we want to do is we just want to select this left edge, okay? And so actually, if you mouse over it really carefully, you can make it so that you just click on that left edge, right? Okay, and so if you click on it, then you'll have that that there. But if you want to make sure that you're only clicking edges, then what you can do is you can switch this selector mode. Okay, and so instead of having Smart Select, what you can do instead is you can have you can change it to this mode right here, which is Edge Selector. Okay, and so the icon for that is kind of like the edge of that cube up there. Okay, so let's go ahead and select this button right here. Select that left edge. Okay. And then now that we have this left edge selected, we can go ahead and apply that. Okay. And so we're going to come down to the bottom left of the screen, and then we're going to hit apply down there. Okay. And then once you've done that, you should be able to see that you're applying this boundary condition to one edge, and then that one edge is indicated by this line right here. Okay. All right. So was everyone able to apply a fixed support boundary condition on the left side of their plate?
Yeah.
Okay, great. Okay, and so now let's apply our pressure boundary condition on the right. Okay, all right. And so same thing, we're gonna apply a boundary condition on the right, and so we need to make sure that we're on edge selecting mode, just like that. Okay, and so now we're going to insert a pressure boundary condition. So let's go over back to the left-hand side of the screen, and then we're going to go to static structural like we did before, right? And so let's right-click that. And then let's go to insert, okay? And then let's go to pressure boundary condition, which is right up here, okay? And so if we read the description for pressure boundary condition, we can see that it says we're going to insert a pressure load that applies a constant pressure or varying pressure in a single direction to one or more flat or curved surfaces, okay? All right, so let's go ahead and click on that pressure, okay? And then let's click on the right edge of the plate, okay? Remember, we're in edge selecting mode right here. And let's go ahead and click apply. Okay. And you can see now that we're now selected this edge right here for us to apply our boundary condition. Okay. And now what we need to do is we need to input the magnitude. Okay. But there's a certain way that we can do it in order to make sure that the load goes in the positive x direction. So it's a tensile force. Okay. All right, and so to do that, first thing we need to do is we need to change how the pressure is defined. Okay, and so on the bottom left of the screen, you should be able to see a setting here called defined by, right? And so right now that defined by setting is called normal to. Okay, and so what that means is that the pressure forces is going to be normal to the surface. Okay, and so it's going to be a compressive force that goes this way. Okay. And so we don't want that. And so what we want is we want to make sure that the pressure force goes to the right. Okay. And so in order to do that, we need to change this defined by setting. And so instead of normal to, we're going to change this to components instead. Okay. And so you want to make sure that your defined by here is set to components. And what this allows us to do is that it allows us to individually set the X and Y components of the pressure force to go in the right direction. Okay. And so let's go ahead and set the X component of this. And so for this activity, I think I set it to be 100 megapascals or 10,000 megapascals. Okay. And you can see here that we're applying this force now in the positive X direction. Okay. All right. So was everyone able to apply a pressure boundary condition on this guy?
I was.
You were? Okay, good. Yeah, I know. I'm going a little bit fast right now just because the time is almost up. But but after the class, I'll be sticking around just to kind of help people just wherever they're stuck. Yeah. Okay. And so now that we've applied the boundary conditions, we have our mesh, we have our constraint, we have our load. Okay. Now we're ready to solve. Right. So we're actually almost done. Okay. And so now that we've reached this point. And you can see here that there's kind of this little lightning bolt next to static structural right here. Okay. Kind of covered it with the annotation. Now we're ready to solve. Okay. And so all you have to do is just click this solve button right here. Okay. And so it's the button with the lightning bolt. Right, so let's go ahead and click solve. Okay, and this is going to solve our, our finite element solution. Right, and so it's going to take a little bit of time. And so if you look, if you look at the bottom left of the screen, you can see the progress bar here. Okay. Right, and also if it's your first time running the Ansys simulation, you might get some warnings. Basically, Ansys is trying to access all your personal data, but it's okay. Ansys is a friendly big brother, so you can allow Ansys to access to all that. It's perfectly fine. Okay. Okay.
Big brother watching.
Big brother Ansys. Big brother Ansys is always watching. Yeah, and so you might get several of them because in the background, what it's actually doing is it's running several different programs. Okay. And so if you click solve and then no errors come up, then you're good, actually. So the finite element simulation was successful at that point. Okay. And so one way that you can check to make sure your finite element simulation was successful is to see if there's a green check mark here. Okay. And so if you have a green check mark next to solution A6, then you're good to go. Okay. All right. And so the finite element simulation is done. But we can't actually see anything, okay? And so, another thing that you have to do in Ansys is you have to tell Ansys, what kinds of results that you want to see, okay? And so let's go ahead and right-click on solution A6, okay? Okay. Oh. Right, so let's go ahead and right-click on solution A6 here, okay? Right, so let's go ahead and right-click this. Go hit insert. Okay. And then first thing we want to see is we want to look at the total deformation. Okay. And so the total deformation will show us, how the plate is deforming or how the plate is displacing, as a result of the boundary conditions. Okay. So let's go ahead and click on total deformation. Okay. And then another thing that we want to look at is the stress field. Okay. And so, one of the big advantages of doing finite elements is be able to do stress analysis, right? And so basically seeing how stress is distributed within your object. Okay. And so same thing we did before, we're going to right click on solution A6. We're going to go to insert, and then we're going to go to stress. And then we want to click on equivalent von Mises stress. Okay. Okay. And so that's going to create these two solution fields. Okay. And then now we need to evaluate them. Okay. And so in order to evaluate them, one way you can do it, you can just click solve again. Okay. And so that'll evaluate the solution fields. But since we've already solved, one thing you can do is you can just right click on solution A6 and then click on evaluate all results. Okay. And then what that'll do is that will evaluate all the results for you. Okay. And then now you can see here that we have a green check mark next to our total deformation field and our equivalent stress field. Right. So let's go ahead and left click that. And you can see here now we can view the total deformation of this plate. Okay. And so this is similar to the plot that I was showing you earlier in the lecture today, right? As you can see here, it's a color contour plot where each of the colors kind of represent a different amount of deformation. Okay. And so let's examine this field, relative to our condition, just to kind of check to see if everything makes sense, right? And so from our condition here, we can see that our plate here is fixed on the left-hand side, and then we're pulling it on the right. Okay. And so generally, what we expect is that near where we're pulling it, the deformation should be really high over here, but then near the wall where it's fixed, the deformation should be 0, right? And so let's check that against our finite element results. And you can see that we see this exact same thing, right? And so you can see in the regions where the area is blue, you can see that we have a deformation of 0. And then where the area is red, you can see we have a deformation of 16.848, which is the maximum deformation in this model. You're getting a different visual plot. What does your visual plot look like?
Looks like turquoise with a green X and dark blue kind of towards the center with a little bit of red on the top and bottom.
Are you looking at this one, the equivalent stress field? And so I was just looking at, so check the deformation field first. Well, we're gonna do
okay.
we're gonna do the stress field after this. Yeah, and so this is just showing the deformation. And so actually, you know, if you're unsure what you're looking at, you can look at this kind of label up here, okay? And this tells you, you know, what field that you're looking at. And so you can see here that, you know, it's showing the total deformation field. The units for this are in millimeters, okay? And so the 16.848 here, that's the deformation in millimeters, okay? And it even shows you the time when it's evaluated, which is kind of nice. Okay. All right, and so that's the deformation field. And so now let's look at the equivalent stress field, okay? And so this is showing you the equivalent stress in the model, okay? And so you can see here that, you know, first let's look at the label here, okay? And so you can see here that the units for this are in megapascals, right? And so the units for stress are always in pressure units, so pascals, okay? And the colors here indicate, you know, where stress is concentrated, okay? All right, and so actually, you know, most of this plate you can see here is a turquoise color. And what that tells us is that the stress in most of the plate is probably going to be somewhere around this value, right? And so in most of the plate, we have a stress of about 10,928 megapascal, okay? But around the holes, like around these areas right here, you can see here that we have stress concentration, right? Because that's where the plate starts to turn red, okay? And so that's where we have a higher stress of about 32,498. Okay. All right, and so were some people able to were some people able to get this this stress field for their simulation?
Yeah, that's the one I was looking at originally.
Okay, great. Yeah, and so that's the activity. And so, you know, I know it was kind of a lot and we went kind of fast. And so there's definitely a lot more details here in the PDF. And so, you know, definitely, you know, even if you got to this point today, you know, I would still recommend that you kind of read through the PDF, especially because, you know, we're going to be doing this process for this entire semester, right? So we're going to be doing, you know, a lot of meshing, a lot of boundary conditions, a lot of looking at results. So I think it really helps to kind of, you know, go through that whole process again. Yeah. And especially for the meshing. And so there's some details on the meshing that I kind of skipped over just for the sake of time. But, you know, make sure you read that because it's, you know, there's a lot of methods in there that we're going to use for, you know, for later on. And I think, you know, if we do have time in a later semester, in a later class, you know, I would like to come back to this just to kind of make sure that we understand everything. But I don't know if we're going to have that time. And so, you know, as you're doing this activity, make sure you kind of read the PDF front to back. And so I spent a lot of time creating this PDF, and so, you know, there's a lot of good instructions there. Okay. All right, and so that's it for this activity. And so, you know, if you scroll down to the end of the PDF, you can see here that I want you guys to try out some additional stuff. Okay. And so, you know, make sure you do all these things and follow all of these instructions, you know, before you submit. But that's it. And so that's the finite element process, right? And so I know we went really fast today, but that's the but you know, that's what we're going to be doing a lot of this semester is, you know, a lot of geometry, a lot of meshing, a lot of boundary conditions, and a lot of looking at plots like this. And so, you know, so congratulations everyone, you've done your first simulation in Ansys, and you know, we're just going to be doing a lot more complex stuff from here. Okay. All right, so thank you guys for tuning in today. You know, I'll stick around for the next, you know, 15-20 minutes. And so, you know, for people that were kind of got stuck at different parts, you know, I'll try my best to help you out. But, you know, if you have to head out, then, you know, then you guys are free to go. And so have a great weekend, everyone. Remember, next week, we're going to be meeting in person. And so I'll send an email about that later today. And I'll see you guys next week.
Professor, can I ask you a quick question?
Sure. What's up?
I'm sure we'll learn this probably later down the semester, but I was curious, is there going to be a way to like use the files we saved from SolidWorks to analyze, like instead of creating a drawing on here?
Yes. And actually that's actually the standard of practice. And so for a lot of the activities we're going to do later, you know, we're going to start with the SolidWorks part, and then we're going to import that into Ansys. And so if you want the quick answer right now, you have to save the SolidWorks part in a specific format.
Okay.
And so I think the two formats that work really well are step files. And so if you save the .step, step, or an IGS file. And so if you save it in one of those formats, you can import it directly into Ansys.
Okay, awesome. Thank you.
Yep.
How will we save the results? Do we just like just save it?
Oh yes, yes. I always forget this, and so if you're still around, that's good. And so to save this, you know, you need to go back to Workbench, and you want to click on Save right here. Okay. And so what that's going to do is that's going to save save your files. Okay. But you have to be a little bit careful. And so you know, let me save this, and I'll show you. Okay. And so I'm going to save this as EGME 410 Act 1. Okay. Yeah, so Josephine, this is going to answer your question too. Yeah, so after you save it, okay, it's going to take a little bit of time to save. Okay. Right. And so if I go to my desktop, right, and so you can see here that it saved this file right here called EGME 410 Act 1. And so this is your Workbench file. Okay. But you know, there's another file, there's another thing that you have to save. Okay. And so if you're saving this to OneDrive, or you're saving this out, you need to make sure that you get this folder too. Okay. And so there's going to be, Ansys saves two things. And so it saves this project file, and then it also saves these, you know, this folder of files as well. And so, you know, if you're saving this to OneDrive, you know, make sure that you save both, because if you try to open this, file without these, this folder, then it's going to give you an error, because this is actually where it stores all the CAD files and the mesh and everything. And then this file right here just opens up all those files. Yeah. And so you want to make sure that you save both, and you save it from Workbench. Yeah.
I noticed it saves a third file up above that where it says file.backup.
Yeah, that's just a that's just temporary file. So actually, as soon as you close Workbench, it actually deletes.
Okay.
Yeah.
I gotcha.
Excuse me, is it w.wbpj? It's just a type of file for the Ansys.
Yes. Yeah.
Yeah,
And so
okay.
that's just the type of a file. Yeah.
Yeah, just too small. Can see.
Oh yeah.
Thank you.
right.
Off-topic question for you is back to the circle. If we want to, like where we saw for the stress where it's dark blue on the left and right, if we made it into oval, will that kind of help reduce the material we use?
Yeah, that's a good question actually. I think oh, so you're saying, you know, because these areas are not bearing that much stress, can we cut them out, and it will save some material for your geometry? Yeah, actually, and later on, you know, we're gonna do an activity based around this called optimization. And so what that'll do is Ansys will kind of automatically determine the regions of your geometry which are not bearing that much weight, and then it'll automatically cut those out. And so it'll actually suggest some design improvements for you. Yeah.
Okay, thank you.
Yep.
Have a nice day, Professor.
Thanks, you too. All right, so was anyone still kind of caught up on an earlier step that I can help out now?
I wasn't caught up, but I had a quick question that I don't know if I'm assuming it's my computer or something, but when I was doing mesh and a couple of other steps before, I noticed that my mouse cursor, as I'm moving it around, is lagging behind and dragging a trail behind it that's kind of sticks on the screen. Once I click on the screen, all of it goes away. But I'm like, it is dragging a lot. I didn't know if there was like a graphic setting or something like I am having an issue with, or
that might be something with your computer. So I will say that Ansys is pretty memory intensive. So it's a lot of work on your RAM in order to run it. And so it could be that, you know, it's kind of overloading the RAM right now, and so it's causing those kind of graphical things.
Okay.
Are you running it on your personal computer, or are you running it on the laptop?
No, I've got it on my PC. I mean, it's got some. I mean, I've got like 32 gigs of RAM, so I've got enough in there that should be fine. But I didn't know if I had a graphical setting set too high within Ansys that caused it to try to be too hyper detailed or something. But yeah, there was that one. And then I know one other quick thing was I noticed that when you ran your simulation, it gave you a graph at the bottom.
Yep.
When, like, if you click on solution A6 or something like that. So, or whatever it was when you ran it, I noticed that graph didn't show up for me when I did it. I didn't know if that was normal or not.
Yeah, so this graph, it's a time graph, and it shows it'll show you things like how things progress with time. And so for our case, we're doing a static situation, and so nothing's really changing with time.
Changing.
And so, this is kind of irrelevant for now, but later on in the semester, we're going to do dynamic simulations, and you'll actually see some stuff actually changing with time here because, stuff is changing with time. But I think I have it open just because I had it open just from a previous, previous activity where I was doing a dynamic one, but, it's not relevant for this one. Yeah.
All right, cool.
Mm-hmm. All right, Kevin, your question is on page 16. Oh, yes, yeah. So that is, I think that is a typo. And so, because I try to modify this activity a little bit year to year, because this is the 4th time that I've reused it. And so for your case, you should use 10,000, not 1,000. But you'll notice in like a lot of the figures, the hole was a lot bigger too. And so that was from a previous case where I put a load of 1,000 on it. Yeah.
You said that this was something that was due next Friday or something like that.
Yep. Next Friday.
This thing. So you're looking for us to, are you looking for us to upload the files or whatever that we have up to?
Oh no. So I just want you to upload just a PDF, and so it'll tell you in these instructions here. And so I just want a single document.
I see it now.
Yeah, so I just want a single document which has your simulation results. So I just want screenshots of them basically, along with, and so there's some stuff you have to write to, and so just make sure you write that. Yeah, good question. So Kevin wants to ask, the graph says ramped. Does that mean it's increasing in linear pressure rather than a step function? Yes. So and so for these kind of static situations, you don't have to worry about that, but internally, yes. And so what it's doing is it's kind of ramping the pressure up slowly up until it reaches its maximum value. And it does this for stability reasons. And so, for a computational model like this, if you take a system and you suddenly force it with a really big amount of force, it can cause some numerical instabilities inside the solution. And I know that term is probably really vague right now, but the reason it does it as a ramp is so that just to make sure that it kind of gets a smooth converged solution. Yeah. So I know there's some terms there which probably don't make a lot of sense, but for static situations, it's it's just to make sure that we get results that are reliable. Yeah. Mm-hmm. Oh, no problem. Yeah. No, I'm happy to answer questions. Yeah, first day is always just a little bit hectic, just because I want to make sure that I finish the activity before the time is up. But but now that the class is over, I'm always happy to answer questions. And so, yeah, finite elements it's fascinating. I think it goes really deep. I think if you really dive into the theory, and even just as a user of the software like this, like there's so much nuance and there's so many features here that there's a lot to learn. And so, I'm really happy that you guys are asking questions, because it's there's a lot to learn, and you guys will see that as the semester goes. And so we've done kind of the most basic of the basic simulations here, but once we start throwing nuance and other features and we start doing 3D, it's going to get kind of complicated. And so I wanted to kind of throw this. I know it's kind of a lot to throw at you guys at once, but I wanted to throw this to you guys at the beginning just to kind of a little bit trial by fire, but then later on, once we start adding more stuff, we're going to add stuff kind of more incrementally. And so yeah, it's a lot, and I'm glad you guys are asking a lot of questions. Yeah.
You said that if we were able to set
Is this
our
lecture going to be
mesh
posted with everyone's questions? Just at least for this lecture, so when I download Ansys, I could reference back to this lecture.
Oh yeah, yeah. I'm still recording right now, and so I'm putting the entire recording up on YouTube. Yeah.
Okay, thanks.
Stephen, what was your question?
Oh, I was just asking, like you were talking about, like, you know, we set our mesh to be a more fine mesh in order to have more nodal points and stuff like that. If we go too high, is like to the maximum amount allowed or whatever, is that something that is just going to take so much like power that it's going to take a really long time in order to get that to actually give you a result?
So in professional settings, yes. And so if you set the number of elements too high, then then your computer will just be chugging, and then it won't finish. But since we're using the student version, and I can actually show you this to you guys, it'll actually stop you way before that. So actually, let me change this down to something absurd like 1. Hopefully my computer won't crash. And so if you're using the student version, the maximum number of elements that you can have is 32,000. And so if you go over that, then Ansys will simply just say, you have too many elements, and then you need to buy the professional one to continue.
Oh, okay.
Yeah.
I see.
And in the grand scheme of things, 32,000 is still really, really light. And so, for a lot of my research, I'm usually working on things with like millions and millions of elements. But granted, I'm running those on supercomputers, and so that's a little bit different. But 32,000 is pretty light, and so you're not going to crash your computer, or you're not going to blow anything up with a 32,000 element mesh. Yeah. So it's still meshing, and so we'll.
Yeah, I was just realizing that like we meshed with something just over 1,000 elements, so nothing that crazy and stuff.
Actually, so the relationship is actually, I think what people generally expect is that, if you have an element size of let's say 10, and then if you cut that in half, I think people generally expect that you'll have twice as many elements. But it's actually a quadratic relationship. And so if you cut, and so for a 2D case like this, for 2D it's actually not that bad. And so for 2D it's actually quadratic. And so if you cut the size in half, you're going to end up with 4 times the amount of elements. And so for 3D it's cubic. And so for 3D, if you cut the size in half, you're going to end up with 8 times as many more elements. And so for this case, since I cut the element size by a factor of 7, I'm going to end up with 49 times more elements than I did before. So actually, I kind of regret doing this a little bit. Yeah. Yeah, great question, Kevin. So Kevin asked a question. So how do we know the results are valid without assigning the material and the material property? Yeah. So that is something that I skipped over today too, just for the sake of time. And so you probably noticed in the problem specs that we have a Young's modulus and we have a Poisson's ratio for this material. And so that's not that's not trivial, and so you definitely need to assign those things. But I chose these material properties so that they match up with the default material in Ansys. And so if you don't specify anything in Ansys, then it'll assign the properties of steel, actually, so structural steel. And so we actually ran the simulation under assuming that our plate was made of steel. But if your plate in reality was made of like aluminum or copper, then you would need to assign those material properties. And actually, we'll spend some time in the next activity, showing you. I'll show you how to actually do that. But you're right. That is a really important point that I kind of glossed over today. Yeah. All right, Stephen, are you still here?
Yeah, I'm looking at it right now.
Yeah,
it's intense.
So you can see here I have 58,000 elements, and so if I try to solve this, I'll show you what Ansys will tell you.
I think it gave you a pop-up in the.
Yeah. So this is the error. So it said your product license has numeric size limits, and so you have exceeded these problem size. So since we have over 32,000, then it'll stop you. Yeah. Which is which I think is it kind of serves two things. Like on the one hand, it gets you to buy the professional one, which is ultimately what they're doing with this is that they have a free version, and they try to get you to buy the real one. But also, since students are using this, it kind of prevents them from blowing up their computer, which is, usually a good thing too. Yeah.
Yeah. The other question, one other question I had, or whatever, is to notice that if I'm not clicked on mesh, I can't see my mesh.
Mm-hmm.
Is there a way to have your mesh like constantly on? previewed?
Yes, yes.
Or-
And so I think there's a, I think it's under display here. And so let's see. So if you go, let's say we go to deformation here. And so you go to display. And so if you click on, I think yours might be, oh, hang on. Display style. It's one of these options here. It's been a while since I've seen it.
Yeah, that's okay.
I thought it was this one. So shaded exterior and edges.
Yeah, that's what I have selected.
Yeah.
I mean, I show my when I click on the deformation and equivalent stresses and stuff like that, the mesh has popped up.
Okay.
But if I was to like click on solution A6, for example, like my mesh goes away, and so I can't see my mesh on my model.
Oh, I think there's a button right here called. Do you have this button right here called Show Mesh?
Yep, the little thing that says Show Mesh.
Yep.
Yeah.
Did that work? Perfect.
Yeah, got it.
Yeah, I knew it was a button up there, but we were kind of looking. It was right in front of our noses, but
It was right in front of my face.
It always happens. It always happens.
Dr. Tran, sorry to bother you, but
No problem.
I just finished reconstructing it again from the ground up,
Nice.
and I'm still having a bit of a problem.
Okay.
It's in regards to getting the pressure attached to the edge on the right hand side.
Yep.
Not sure why it's not connecting at all. My first mistake was that I forgot to give it a thickness. So I just recreated the entire thing from the first step. I made sure that it had a thickness of 5 this time. And I was just basically following the PDF, but right now I'm kind of stuck here trying to determine what's wrong. I can't really.
Do you want to share your screen? I think it'll be easier for me
sure.
to debug it that way.
Yeah. Can you enable that?
Oh, yes.
Thank you. All right, is that visible?
Yes.
Cool. Yeah, I've been trying to at least get the selection for the edge.
Yep.
But I'm not sure why it won't allow me.
So can you rotate your geometry a little bit? So yeah, okay. I think for yours it might be a so go ahead and left click pressure again on the left hand side. Just left click it.
Oh, left click.
Yeah, and then go ahead and go into geometry. Click that. Okay. I see. I think you might be in 3D mode, and so can you go back to Workbench?
Workbench.
All right. Can you right click on geometry and then click on properties?
Properties.
Yeah. So do you see analysis type?
Yeah.
Don't change it to 2D. Yeah.
Okay.
So go ahead and close mechanical and then reopen it again, and then let's see if that works. Yes.
Okay.
Okay. All right. So let's go ahead and left click pressure again, and then click on geometry. Nice. Okay. Yeah. And so let's go ahead and click that right side. Perfect.
Perfect. All right.
Perfect.
Awesome.
Perfect. All right. So let's go ahead and click solve, and let's see if this runs. Click allow access. They're just trying to steal your personal information.
Yeah.
It's okay.
Everything's been exposed. I'm good. What more can they steal from me, honestly?
They can steal my student loans if they want them.
There we go.
Okay, looks like it succeeded. And so let's go ahead and create the deformation field and then the stress field. Yep. So right click. So let's put the stress field in there too. Yep. Stress equivalent von Mises. Okay.
And I just evaluate all results, correct?
Perfect. Yep. Right. So let's go ahead and click that. Perfect. Yeah. So this looks great. And so you put the refinement around the holes too, which is excellent. And so in the PDF there's a little bit of a typo. And so for the PDF I put a load of 10,000 megapascals. But I know later in the PDF I say 1,000. And so your deformations here are 10 times less than mine. But that's okay because it's and so you can just go ahead and change it. And so instead of 1,000 here, and so on the bottom left you can go ahead and change that to 10,000.
Then I resolve.
Yep. Mm-hmm.
Oh.
That's gibberish. You don't have to look at that. All right, solving. Oh, click on total deformation again.
Total deformation.
Yep, perfect. Looks great. You'll get equivalent stress.
Can't really tell the difference, but all right.
So it's in the numbers, and so if you look at the total deformation, the colors look exactly the same. And so let's go back to total deformation. And so if you look at the numbers on the color bar on the left, before you had it was like 1.6848. But since you increased the load by a factor of 10, it increased the deformation also by a factor of 10 as well. Yep.
That's really cool.
Yep. Yeah,
Nice.
and so that's finite elements, and so yeah, we're going to be working on this process, throughout the semester. So.
All right, awesome. Thank you very much, Professor. Really appreciate that. I'm
Yep,
definitely
no
gonna keep
Yep.
retrying this till it's 6.
It's it always happens. People it's always hard with the large group like this, especially with Zoom. Because undoubtedly some people have certain issues at certain points, especially so Ansys itself is a really finicky software where like it'll have like weird errors where even I don't really understand all the errors sometimes.
Right.
And it's really hard to kind of get around to a lot of people in a large class like this. But usually when I have these activities, I like to stay afterwards, just to kind of make sure just to kind of catch everyone up. So
And also,
glad.
thank you again.
Yeah, no problem. Yeah, glad you're able to get to the end. So.
Dr. Tran?
Yep.
How do I screenshot the the model, or is it like a button?
Yeah, and so if you go to, I think there's a screenshot button within Ansys, but actually usually what I do is I just use the clipping tool within Windows, and so I just screenshot and I clip, and that's what I do. But there should be a button here somewhere. I forgot where it was. I learned where it was before just because someone asked me about it, and then I forgot where it was.
No worries, you're good.
Okay.
Just, snipping tool.
Yeah. Snipping tool works just fine. Yeah.
Thank you.
How do we save this again?
Yeah. So you want to go back to Workbench, and so on Workbench, you're gonna save it from there.
Oh, so I don't save it from. Oh wait. Oh, it's okay. So Workbench automatically saves it from me, even though I hit save from the mechanical.
Yeah. So you want to save it from Workbench because that saves everything. Because remember, we launched Design Modeler from Workbench too, and so you want to make sure you save the CAD and the finite element results, and so it'll save kind of all that together for you.
Okay. Type with full. What about the file type?
It'll automatically save it as a, I think, WBPG file or something like that. And so yeah, you don't have to specify a file type.
All right, cool. Thank you.
Yep.
Yeah, Chris, you're gonna get like 3 files. Well, until you close out your thing, but yeah, you're gonna get 3 files. One's a folder, one's the file.
Yeah.
That freaked me out at first. I was like, wait, what did I do? I just downloaded everything again? What did I do?
Yeah, I was trying this earlier with my MacBook, but it gave me an issue where like it just shrunk the font, so it was really tiny to see. So I decided to just go to desktop.
Wait, you're running Ansys on a Mac?
Yeah, I bought Parallels and I saw Windows on it, so I was running it through there. It was really smooth. I was surprised. But I just wish that it wasn't tiny font. So I gotta figure out that fix.
I see.
It's been working good. Like I'm on my desktop right now, but I was playing around with it the other day on. I just got a Dell XPS, and I guess it has like its own dedicated graphics or whatever, and the thing is amazing.
Nice.
Still, I mean, it's a laptop, so it's not going to be as quick as my computer or the ones in the lab or whatever. Yeah, it's still pretty good.
Nice.
All right, thank you again, Dr. Tran. Really appreciate the help, and
Yep.
also you staying. Really helps a lot.
Yeah.
Hope
Yeah.
you
No
enjoy the
problem.
rest of your night and your weekend.
Thanks. You too.
Thank you.
Yeah, we'll see you next week. Have a good one.
All right. See you guys next week.
Good, Dr. Tran.
All right. See you guys.